Hello all. Today's video is an extension of the previous video which I made on Bluechii from RedHat. So today we'll be talking about another concept called QM partition, which is basically one of the feature provided in the AutoSD operating system, which is created by RedHat. So if at all we see with respect to the software defined vehicle ecosystem in the car, basically going forward, lot of third party applications will be running besides the company provided OEM provided softwares, maybe for ADAS or anything like that. So there will be an app store, and inside this app store there might be multiple applications which the user would like to use. So this basically creates a kind of a concern for the car, because say there are, as an example over here, there are 4 SL applications and there are 4 QM applications. So you can see SL app 1 2 3 4, and similarly you have QM app 1 2 3 4. Now these QM applications, so these are provided from third party. Say one among this particular QM application has a what do I say, maybe some bug, or it might be infected, or it could be of any reason, it could be vulnerable. Now because of that specific QM applications, in this case the QM app 2, there is a high chance that any hacker can basically access this particular container, because of which he might affect the running critical SL applications and the other QM applications as well, which might be quite dangerous for the host, in this case the HPC, which is shown over here, that the host machine can basically be infected very badly and it can even turn off, which could be a very risky scenario when a person is basically driving the car. So how do we overcome this? So this is where RedHat has created something called as a QM partition. So this I have discussed in my previous video, part 1 of 2, with Bluechii from RedHat. So here is the HPC. So here there is a systemd, there is a podman, and they have a podman runtime in the normal partition, and there is specifically a QM partition inside which all the QM related containers and some of the non container based applications, maybe like some binaries, or it could be a virtual machine for running Android Auto or anything, will basically run in QM partition, and any spillover from this QM partition into the SL application area or the main area is being obstructed by this particular QM partition. So this is basically the block diagram. So they have the SL, means the host by default it is considered as the SL partition, and there is this particular QM partition. Inside this QM partition, so this particular QM partition basically runs as a container inside this particular SL partition or the host. So this particular QM partition is nothing but a container running on this particular podman on the host, but this QM partition as such has a container runtime of its own, which is another podman. So it is like a nested container concept. So what they're trying to bring in is, like, in this QM partition there could be multiple applications. So earlier we can see that the containers Q1, app1, app2, app3 and app4 were running alongside with SL. So that is not the case now. So what they're telling is, you run all your QM applications over here, the third party applications as well over here, instead of controlling or restricting each and every particular application, because there might be some mistake which might happen. Say for one particular container which is running, say the PID is not, the process is, they are not restricted. So say someone runs a fork bomb, then that would screw up the entire system. So in order to avoid such cases, so what they're trying to do is that they will restrict, they will provide hard policies for this entire QM partition as such, with respect to how much CPU resources it can use, how much memory, what is the PID, and many things, along with the SC Linux policies and other things. So as all the other containers will be running inside this, they will basically inherit the properties or the, what do you say, the rules of this particular QM partition into them. So because of that, say some malicious activity is being run by some particular application over here inside the QM partition, that will not go beyond this particular QM partition. So that is the basic idea behind this particular QM partition from in AutoSD from RedHat. So here is the example. So this is the host machine. So you have a BlueChi controller over here. So this host machine has the BlueChi controller, and the host machine as such is also having a BlueChi agent. And there is this QM partition. This QM partition also has its own BlueChi agent. The host machine has its own podman. Similarly, the QM partition also has its own podman. So here is how you can see. So this is the host machine. Inside this host machine, if at all I do a podman PS, you can see that the QM app is basically running. The QM partition is basically running as a container. And when I do a BlueCTL status, you can see that the host is online, which is nothing but the actual host. And the QM partition is basically called as qm.host, which is also online. Now, if at all I see basically the list of the controllers and the agents, so you can see that the host is having the BlueChi agent, the host is having the BlueChi controller, similar to how I have explained over here, and the host is having the BlueChi agent, similar to how this is over here. So with this being said, so this is how the AutoSD's QM partition looks like. Say something is affected over here, it will not spill over into the SL application. I vaguely remember reading it that this particular QM partition will not even, this particular containers manipulation or whatever will not spill over even into the other containers running inside the QM partition also, is what I have read. I vaguely remember. I will anyways link the corresponding article where I have read in the description of this video. Maybe that could be of use for you guys. And there is another small, so this is one use case. So say this, as I said earlier, once this QM partition is basically created, it is provided or it is restricted to some specific CPU memory resources or many other policies and other things as such. So say for some reason, the QM partition is given 40% memory resources. Say this is an example. So unlike in QNX, so this particular partition being given 40% is not a hard limit. So what it means is the maximum value to which this particular QM partition can take is 40%, but it cannot go beyond 40%. So in the case number one, say the SL partition or the SL apps are basically using only 40% of the resources. The QM partition is having 40% of the resources. There are 20% of free resources which are available out there. I am talking about the entire host. Now say there are some applications in the QM partition which wants to access more resources, because here you can see 20% of the resources are free. That is not possible because the QM partition as such has been restricted to 40% of memory usage. Now say the SL application consumes the free 20% also because some other application is running. So here in this case, basically 60% of the applications will be using SL and the rest QM containers will be restricted only to 40%. Say for some other reason, now this SL applications want to consume more resources, so it wants maybe 20% extra. So from where it goes is the QM partition which has a maximum limit of 40%. Though these containers are entitled for 40%, but the priority is given only to the SL application. So the extra 20% of the resources are pulled from the QM partition onto the SL partition, so that the applications inside this particular QM partition basically will be starving, or there might be, or the whoever is using this particular thing has to write a code so that the resources he shuts down some of the low priority QM applications. Now for say some reason the SL applications need all the 100% resources, there is a provision provided by the RedHat people where the entire QM partition as such can also be made to disappear. So in this way, the QM partition, which is basically a container, is controlled in such a way that the SL applications or the SL partition, as we discussed over here, has the highest priority, and the QM applications are given low priority, so that at any cost the SL applications don't have any kind of issues while running. So this is basically an overview and the workings of how the QM partition works and what is its advantages in the automotive use cases. Thank you for your time. Thank you all.